Hi everyone, my name is San. Welcome to Tech Build with San. Today we will be looking at very interesting topic known as the in-memory database processing. And imagine you don't want to develop an application using a database. And why you want to do that? The first thing, you're going to lower the data usage cost in cloud, because cloud provider is very costly these days. And if we use the in-memory database, and it is ultra fast in-memory data processing, and it is a simple development, you don't need any SQL knowledge or no SQL knowledge. It's only the knowledge of Java objects, how the Java objects are used. Even you can use new records in Java, all new Java features. So this solves the infrastructure cost, and it is very fast compared to the normal how the applications we build. It only requires knowledge of real database, real Java objects, nothing more, and it is ultra fast. So what problem that it solves? The problem that it solves is that because we have an object relational model these days, ORM. So during the ORM process, if you can see it over here, this is a JPA solution and this is a MicroStream solutions. So these two are database. This is RDMS and this is NoSQL. So while from the applications, all the Java objects, they need to be mapped to either SQL RDMS objects or NoSQL things. So there is a serializations and deserializations of these things happening before we call our database and before we fetch our database. Now during this process, this takes a little bit of time when you do serialization and deserialization. That's why sometimes there is an exceptions in the query. We get longer period of times if there are long data, very large huge amount of data. So MicroStream solves that issue. So we don't need to serialize and deserialize the RDMS and NoSQLs, because data is just an record. There needs to be persistence in anywhere. It's maybe either in cloud or in memory database. So this solves the issue of persistence, and it is very ultra fast. So if we compare this to a diagram, in the left side we can see this Java object, which is an object graph, because it stores everything as a graph. So if you have a knowledge of data structure, all maps, link queue, how those store the data, the same concepts applies here. And it is very useful in these days like microservice architecture, because one service will not have a huge data and they have a different database, and you don't need a different database for a small applications like a small service. You need just a small portion of size. So for that, why you want to have NoSQL or Postgres or RDMS, any other database? Just use the in-memory database and they're very fast. And that's what this MicroStream solves. So MicroStreams are basically for Android and Java. It's all their codes are written in Java. If we check the GitHub, they have everything they have written in Java. So it's 99.9% is all pure Java. And it does support Graal VM and other new technologies that are coming, and it's very ultra fast. So this works for Android and this works for JVM web applications. We will be looking at web application, and is that support currently now 3 frameworks: Micronaut, Helidon and Eclipse. We will be dealing with Micronaut on this one, and we will use Micronaut for this one. So there are fantastic benefits: high performance, lower data cost, and it's very simple to develop anything because you don't need any extra knowledge for this one. So let's start how we can use this one in our Micronaut application. So in the Micronaut.io launch, so I will be just, because this is a regular Micronaut application, so how you will generate a Micronaut application is either from CLI, or you can use VS Code extension Micronaut, or you can use IntelliJ to create an application, but this is UI things. It gives some visualizations. They're very easy. So over here I will click feature different things on here. One is cache. The MicroStreams does also works with cache. If you need the same problem that Redis solves, the same problem this solves. If you want to use a cache distribution caching things for this one, so you can use a MicroStream cache. And this is a database that this will replace an database with this in-memory database. And if you want to see all the graphs in your local development, so you can use a MicroStream REST. So we just need, if you are using cache, then you can use a MicroStream, but if you are not, but you don't need to. We'll be using development tool and database for this one. So once we select this one and create a project, so if you download the project will be like this. I have structured the project, and if we see the build.gradle file over here, so if you see the build.gradle files, we will have a MicroStream, one annotation process that is required, and there will be two implementation of this MicroStreams, one for annotations and this for the database. And if we are using that REST API of MicroStreams, so this will be a development only module, so we will add over here. So these are the three dependencies that we need in order to execute the program. So this is a regular Java applications with Micronaut application. So I have a controller which is named as the best, and is one of the method is post. In this post method I have a repository which is an interface, and it has implementations or dependency injection as singleton over here. Then I have one of the method over here. Now in MicroStream we have this root provider. So it requires a main object to process the data. So this is the top layer of a tree. So MicroStreams work based on the graph. So it requires the first node of the graph. So from that nodes, it's if you create a multiple objects, how you create an object in Java, all those things will be based on the graph. So it will need to know which is the main node of the graph. For this one, in the resource, we need to specify which is the root class for this one. So, and this is a storage directory. Currently I have given the build, and this is a new folder. If that folder does not exist, it's gonna create a new folder. And for the storage, we can either use the application storage, or you can use storage from the cloud. We can use a Postgres as well, or you can use MySQL, but this will not create a database in the Postgres SQL. It will be as a blob storage in the SQL. So you can use it from here, but it will not create any data storage. But still you can store your data in database if you want to persist in the database, but the recommendation is used to the cloud provider storage. So you can provide storage. So if you go in documentations of Micronaut, because we are dealing with Micronaut, so if we scroll down to the storage section over here, so if you want to use Postgres to store your all the things, remember this will not create a database, but it will create a blob storage on the Postgres. So in the Postgres you need to add these dependencies, and in the data source you need to provide an URL and username and passwords. Recommendation we used to use either if you are using Amazon, so S3 bucket, or you are using Google or Azure, you need to provide the storage cloud provider. So this is the S3 with bucket name and root class name. So this is how it can store the data. If you are using DynamoDB, the same thing goes here, and if you are using cache, you need to include this thing. In this example, I'm not going to use a S3 bucket or anything. It's gonna be in the applications, like in my local storage. So I have given a local directory as build folder. Then it will, if build folder will be exists, but order that storage will not be exit, so it will create that one, and we will have a files over here, micronaut. So because I told my MicroStreams required a root node to process your object, so we need to define an root class for this one. So over here I have defined a root class as this one. You can use a record if you are more comfortable with record, and it supports all the latest features of Java. So over here I'm using a map because map is more faster than others and is a concurrent hash map. So you can use all data structure that Java and provides, so you can use for better fast access. It's just you need to have a knowledge of Java, that's it, you don't need anything. So it's one of the objects, it's my record, which is serializable because I'm using Micronaut, and Micronaut has a annotation process for serialization. So this is one of that, and I have these three properties. So this was the container, and if I check one of the repositories that is calling over here, and this is the create method that my controller calls. Base controllers calls this create method, which is the implementation of this one, and I have a small method over here which is called then store params. This because I am using a MicroStream annotation process, for that one I need to specify this storage param, because it needs to know what was the storage param so it can return. So over here I am passing from getting the value from this. So if I go to the build folder of this one, if you go this one, see I have order storage, but remember this order storage, because I have run these applications and already have invoked one of the API, that's why this folder has been created. But if you have not created invoke an API, this folder will not appear here. So it creates only if you have invoked one of the API and access this one. So over here I can see these are all the binary files, because MicroStreams store everything in the binary format, so we cannot read, human cannot read those binary files. For the better fast access of the data, they have went through this technology with binary storage, so they all do binary encryptions, so we cannot read the data, but this is the data how they store it. It's the file format of that and PTP. So over here I'm accessing data, and I am creating and just putting, this is not a new concept, I'm passing that map over here, which is one of the method, and it's just putting the data over here. So if I run this application, so it started very fast. So if I run this application, so I will get this one as this one, because this is like 13 millisecond, 11 millisecond, because you might be thinking this is just a simple applications that's storing and 3-5 objects, and it doesn't have lots of data. That might be, yeah, here I'm getting 17 milliseconds for this one, but believe me, I have implemented these things on a very large applications where you have tons of millions of data. Even at that time, this processing is very fast. If you like my content, please do subscribe to my channel and hit a like button or give a comment to me, so that it makes really interesting for me to create a new video. And thank you for watching.